Hello everyone. So in this video you will be learning lesson 5 of chapter 4, which is about triangle congruence, and we are going to learn to prove that triangles are congruent by using the properties of SSS and SAS. Now what does this SSS and SAS means? SSS means side 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 and SAS means side angle side. You will get to know about them in detail once we start the lesson. Now the property of triangle rigidity gives you a shortcut for proving two triangles congruent. So in fact this rigidity, that is the triangle rigidity, is a shortcut for proving that two triangles are congruent. So let's see what that means. So this is the first property which you have, which is SSS congruence, or the side 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 congruence. What does the side 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 or SSS property say? It says that in a triangle, if the three sides are given, in another triangle also the three sides are given, and if they both are equal to if both the lengths of the corresponding sides are equal, that means both the triangles are congruent. I'm repeating it again. If three sides of one triangle is congruent to the three sides of the other triangle, that means both the triangles are congruent. So let's look at an example by using the SSS property to prove triangles are congruent. So they will tell you, use SSS to explain why this triangle is equal to this. It is given that, so here we start by saying these three sentences are going to be common for all the questions when they say explain why. So keep in mind, when they say explain why, the sentences are going to be common for all. Only these will differ. Of course, because figure will differ, definitely these are going to be different. Now from the figure you could see that AD is congruent to CD, right? Also AB is equal to CD. So if you're confused here, you can use always the statement AB is congruent to CD, BC is congruent to DA. So start by saying the first sides. That is, it is given that, this is common for all, AB is congruent to CD. Now always follow the order. Here AB is congruent to CD and BC is congruent to DA, right? So this is the first sentence you're going to say. Now the next sentence is going to be by the reflexive property of congruence. Reflexive property means it states that two sides of an equation are equal. So here, because we are talking about congruence of a triangle, that's where they use the word reflexive property of congruence. So if something is equal to the same thing, we say it is reflexive property. So we already said two sides are equal because we have to use three sides. It says SSS, which means three sides. So here we have one side. Here we have another side. So the third side is going to be AC, which says by the reflexive property of congruence, AC is congruent to AC. Therefore, triangle ABC and CDEA are congruent by SSS property. It's easy, just that you need to concentrate a bit on the segment order. That's all. Let's try out a question or two and check whether we could do this. Okay, here. Now this says in triangle RST. Okay, leave that question aside. I will start from question number 2. Use SSSX to explain why the triangles in each pair are congruent. So we have to start by saying it is given. As I told you, those sentences are going to be the same for all. It is given that, start from any one side of the triangle. So let me start with AB. So which is the congruent side of AB in the other triangle? It is going to be CD. If you're not sure, you can use this, AB, CD. That AB segment is congruent to CD segment. And which is the other segment which is congruent? AD. So AD is congruent to, which is the congruent side of AD? It is going to be CB, congruent to CB. Then the next sentence is going to be by the reflexive property of congruence, which part is equal to what? BD. This is the same command line for both. So we say BD is congruent to BD. Therefore, now we have proved all the three sides. This is the first side, this is the second side, and this is the third side. So finally we say, therefore, triangle ABD is congruent to triangle CDB. That's it. This is how you explain why the triangles are congruent. Let's try one more. This is triangle MNP is equal to triangle MQP. So always start by saying it is given. It is given that, take any two sides first. So let me take M and N. So that MN is congruent to, which is the congruent side of MN? It's going to be MQ. Not sure? Look at this. MN is congruent to MQ. Follow the same order. MQ. And which is the other side? We have NP. So NP means it's going to be QP. NP is congruent to QP. Then, by the reflexive property, that's going to be a second statement, by the reflexive property of congruence, okay, which is equal to what? The common side, which is MP. So MP is congruent to MP. Therefore, triangle MNP is congruent to triangle MQP. And you're done. This is how you use the steps to prove that two triangles are equal. Now let's move on with the lesson explanation. Now this was about SSS property. Next comes the SAS property. But before that, we need to know what is an included angle. An included angle is the common angle between two sides. For example, AB and BC. So the common angle between AB and BC is angle B. So we say it as the included angle. Now, what does the SAS property say? It says that if in two sides of an angle and the included angle of one triangle are equal to the other triangle, that means both the triangles are equal. So this is what the SAS property says. If two sides and the included angle of one triangle is equal to the congruent sides and the included angle of the other triangle, that means both of the triangles are equal. Let's look through an example how it is going to be. Use SAS to explain why triangle ABC is going to be congruent to triangle DBC. Okay, the first step is going to be, you're going to use the same way. Only the difference is, rather than writing a side here, we are going to name the angle because it is SAS, side, angle, side. So it is given that AB, so start from AB, is congruent to DB. You know now how to find the congruent sides well. And angle ABC, now we are referring to the angle because it should have one angle. So angle ABC is congruent to angle DBC, which means these two angles. By the reflexive property of congruence, BC is congruent to BC. That's the common side. Therefore, triangle ABC is congruent to triangle DBC by SAS. So you need to mention the property which you have used. I think when solving, I forgot to mention the property, but you need to mention the property because they said use the property. So you need to finish it by SAS or SSS, whichever property they want you to use. All right, let's go forward and check how can we prove two triangles are equal when the value of a variable is given. So here, triangle ADB is congruent to CDB. You have to show that when t is equal to 4. So the first thing you're going to do is solve all the expressions, the variables which they have given you, solve them first. So here I have 1, 2, 3. I have three expressions here. So I'm going to solve each of them. So AD is 3t plus 1, which means you will replace the value of t with 4. So that's going to be 13. Same you will do for CD. You will replace the t with 4 and solve it. And finally, we have angle CDB. CDB, because how do you differentiate between the sides and an angle? For an angle, they will mark with the degree sign. So this means it's an angle. This doesn't have the degree sign, so that means it's They are the sides. So you will do the same. You will replace t with 4 and find out the measurement of the angle. Now comes the part where we are going to start proving that these two triangles are equal. So start by the sides. We could say that AD is equal to DC because AD is equal to CD because of both of them are 13. When we solved, we got this also 13 and this is also 13. So we could say AD is equal to CD, which is 13. So from this statement, we could say that AD is congruent to CD because of the definition of congruence. Okay, so we are done with one side. The next one is the angle, which is angle CDB, which we found now. CDB is equal to angle ADB, which is 32 degrees each. This one they already gave 32 and this we found out to be 32. So both of them are equal. So we could say that angle CDB is congruent to angle ADB by the definition of congruence. The last proof is that dB, the common side, is going to be equal to dB because of the reflexive property of congruence. So now we have two sides and we have an angle. So we are using SAS property here, two sides and one angle. So this means finally you could say therefore triangle ADB is congruent to triangle CDB. Let's put that into practice here. First, you need to find the value of the variables. So here I have two expressions. The value of the variable is x is equal to 4. So this is 3x minus 9, which means I need to solve hi equals 3x minus 9, which means 3 multiplied by 4 minus 9, which is going to give me 12, minus 9, which is going to give me a 3. So this side is going to be 3. Next side is ij because that has an expression 2. Ij is 2x minus 3, which means 2 multiplied by 4 minus 3. That's going to give you 8 minus 3, which is going to be equal to 5. So which means this side is going to be 5. Now you can see this is 3, this is 3, this is 5, this is 5. So let's start writing the proof. So first start by the side. Say that HI is equal to HG. The measurement of both of them is 3. That means I could say HI is congruent to HG, right? Because of what? Because of the definition of congruence. This is my first statement. Now, keep in mind here I have the measurements of for 3 sides. This one, side 1, side 2, and side 3. So I need to have 3 statement proofs. So 3 proofs for, 3 statement proofs, fine. The next one, now talk about the next side, which is ij. Ij is equal to which side? Gj, which is the measurement, which is 5. So I could say this is my second statement of proof, which says that Ij is congruent to Gj because of, again, the definition of congruence. So this last statement of my proof is going to be Hj is congruent to Hj. Why is that? Because of the reflexive property of congruence. This is property of congruence. So finally, you could say, therefore, triangle GHJ is congruent to triangle IHJ. You could say by SSS, or you can just leave it like that because we used SSS, 3 sides, right? Let's try one more. This is, if you have not done, do it by yourself and then you will check with me. Okay, so you can pause the video here, do it and then check it. So this is going to be, again, I need to solve first the expressions. So let me start by solving UT. UT is going to be 4x minus 11, which means I will replace x with 18 because they gave x is 18. So this is going to be 72 minus 11. So 72 minus 11 is going to give me 61. Okay. Now let me move to 2x degree. Now this is an angle. You can see this degree sign, which means it's an angle. So I have to name the angle. Let me name it as UTR. UTR. Angle UTR is 2x degrees, which means 2 multiplied by 18, that is 36 degrees. So I found this to be 36 degrees. I found this to be 61. So I can use the properties now, right? So let me start by saying first UT and RS. So I will first write the sentence, that is UT equals ST. UT equals 61. So 61 means SR, which is going to be 61. So I could say UT is congruent to SR because of the definition of congruence, right? Then this is my first statement. Now I'm going to use here SAS property because I have two sides, angle and side. So let me talk about the angle next. That's going to be angle UTR is equal to which angle? UTR. If you have problem, follow this order. UTR means here it's going to be SRT, right? SRT angle, which is equal to 36 degrees. So my second statement of proof is going to be angle UTR is congruent to angle SRT because of what? Because of the definition of congruence. Now finally the last statement, which is going to be RT, because we have already talked about the other sides, right? So the final statement is going to be RT is congruent to RT because of what? Because of the reflexive property of congruence. Now, if you want, you could also use RU and ST. Okay, now they are parallel sides. So you could say RU is parallel to ST. This is an extra statement for your proof. So it's better to add extra, but for now, don't confuse yourself with that. But if you're writing, you could say RU is parallel to ST. Okay, and you could say definition of parallel lines, because you know two parallel lines are always equal. So final statement is going to be, therefore, I did not write therefore, RST is congruent to an triangle TUR by, if you want, you can write by SAS, or you can leave it here. So this is how you use the SAS and SSS property to show the congruence. Hopefully this lesson is clear. Do more practice. Definitely you will get the lesson more clear, because it's not a difficult one, just that you need practice, that's all. So until we meet again in another video, keep practicing.